Hi, in this video we will implement the KNN in Python. In the last video we will see the basics KNN and where we can apply the KNN and where it is not good to apply and what are the some problems that we have in the KNN, how to solve those problems. We are some before videos. Okay, in this video we will implement the KNN in Python. Okay, for this we are using the libraries like NumPy, sklearn are the basic libraries that we are using. These are the libraries which are mostly used in the data science field. Okay, for this we are using the basic data that was the iris data we are using for this purpose. We know the iris is a basic example for the classification problem. In this data we have three classes. Okay, but actually in the model algorithm, any algorithm, to check the model we need to train and test data. Because we train the model by using train data, we check the how the performance of model by using the test data. For that we split the whole data iris data into train and test. Okay, here point to represent 20% of data is test data. Test is equal to 0.2, so the 20% is test data, 80% is train data that we are using. Okay, we will see how the data is look like. Okay, that will be fine, I think. Yeah, yeah, these are the four independent features. These are the sepal length, sepal width, petal length, petal width. I think these are the features. And we have the class labels. The class labels we have Sotasa versicolor Virginica. Sotasa represent 0 and versicolor represent 1 and Virginica is represented with 2. Because why we represent like this? Because um, the algorithm don't accept the text data, it only accept the numerical data. That's why we are represent 0, 1, 2. Okay. Now coming to the implementation. Okay, in the KNN, yeah, in the KNN we will find the nearest neighbors. We need to find the nearest neighbors. Okay, how we'll get the nearest neighbors? By using the distance. Distance is the one thing and similarity based method is another thing. We use the distance, that is Euclidean distance, that we are using. For this we are created a function that is Euclidean distance. We'll find the distance between 2 points, that is the Euclidean distance, it will be fine. Here for this we are using the NumPy array. We know the formula for the finding the Euclidean distance. Okay, next we will create a class. Here we creating a class. Here this is the construction and has parameter k equal to 3. It was a default, but actually in finding we'll find the k value by using cross validation technique, by using the best k value that we will use here actually, but it is a example. That's why we are directly using the k value. Okay, when you are in the practical examples we are only using the cross validation check method. By using that we will get the best k value that we directly use in the model. We don't directly give the k value. Okay, and then fit is a function method, sorry, fit is a method in the KNN class. Here x y are the two parameters. These two parameter values assigned to this variable x10 and y10 is the variable. These values assigned. Then predict is a method. Predict is a method. In this predict we generally here we will give the test points. Okay, test data we will give as values to this as a parameter. When the test data every point call this predict method slash predict method. When calling this predict method it has a parameter, that means this is the test point. For every test point it will find the Euclidean distance. Okay, here we can observe it will find the Euclidean distance, that is function. that we used here. For for a, for every extend point, that means we splitted 80% of points in the train. Okay, those 80% of points we will find the distance, okay, with the quarry point. Okay, those all distance stored in the form of list here. Okay, in the distances we have distances of quarry pointed with all the train points. Okay, okay, but we don't need the distance, we just need the class labels. Okay, for this we are finding the sort, we sort the based on the sort, we use the arg sort method. By using the arg sort we'll get only indexes. Okay, we'll get a 3 4 7 like this, we will only get the indexes only, we won't get the values. Okay, but we just need only k points. Here k is 3, we get only first 3, that means indexes of short distance points. Okay, by using those index we will find the class label. Okay, we will get the class labels like any neighbor labels. Okay, but by using those labels we will use the most common. By using the most common we will get the which are the most of times occur. Okay, it will return which class is belongs to, that was written here. Okay, for every test point it will predict which class it belongs to, that was stored in the by predict. Okay, that was written by the predict method. Next, okay, now we created algorithm, but we need to know, we need to check the how the performance, that means how it is performing, that we have to know, because if its a performance is good then only we can accept, as we don't accept this model. Okay, for this we are using the, we created a function accuracy, and it has parameters y true, y predicted, that means actually true, y test, and y predict. What are the predicted by the KNN method, KNN algorithm. Okay, those two values we will give. Here we will, this was represented y true equal to, that means when the y true equal to y true, that means the accuracy, we will find number of correctly classified by total number of points. Okay, number of correctly classified means y true equal to y predict, that means it is classified as 0 and prediction also 0, then only it is true, else it will be false. Okay, by the, and the length number of points is the total number of points, length of y true. Okay, now coming to this one, here we will given directly k value, but in the practically we will find the k value by using the cross validation technique. We'll call the class KNN class. Okay, we will give the k value and we will fit method, and we use the predict method, then we will get the class which class it belongs to. Okay, and these we will check the accuracy, we'll get this value. If we change the k value, the value also changes. Okay, we'll see this one also. Here let's use k value is 5. Okay, this accuracy also changes. Okay, we need to use good k value. Now we can also implement it using the sklearn library. Same thing, we can directly import the KNN class, and we call this number of neighbors that we given k value equal to 3, that we are given, and we will fit method. By using fit method we will extend y tray, then we will predict the method. By using predict we will get the prediction, and same thing it will work, it will be as same as above. Okay, let's now see the go to the this one, we will see here also. Yeah, this is the thing. Here we have number of neighbors is a parameter, weights, algorithm. These are the metric. We will see these four things. The n neighbors represent, that means a k value. This is the k value. And weights, weights we know the uniform and distance. We will give the, yeah, where in the last video we will discuss, we will give weights based on the 1 by distance. That is the thing here, distance. But default we are using uniform method, uniform as a parameter. Okay, in this uniform we will consider the point, this if any distance we consider as we don't uh, we don't follow the distance. Okay, these are the all we consider as one. Okay, if we given weights, that means it will get more weight, it will get less weight, it will get more weight. Okay, that is the thing. And KD tree, we know the methods. These are the methods, different algorithms that we can use, okay, to avoid the time complexity problem. And the metric, the metric we are using Minkowski with p equal to 2. That means we are using the Euclidean distance.